Hey all, so today we're just going to be doing some more problems on logarithmic equations and exponential equations in solving. So this first one we have 2 log base 5 x equals log base 5 9. The first thing I'm going to do is change this into the exponential form on the left side. So that would be log base 5 x squared equals log base 5, 9. Now that I have the same base, I'm going to drop my bases of the log 5 and say x squared equals 9. If I take the square root of both sides, I get x equals negative 3 and positive 3. But you have to remember that with the domain of the log function, x has to be greater than 0. So we can eliminate the x equals negative 3. Alright, for this next one, we want to use those log properties and change the left side. Since we're adding 2 logs with the same base, you can combine them and multiply. So log base 5 of x plus 6 times x plus 2 equals 1. And then as a side note, if you want something that equals 1 with a log, it's log base whatever to the same. So log base 5 equals 1. In our equation over here, we have a log base 5, so that's why I'm using 5 here, so we can have a common base. So log base 5 of x plus 6 times x plus 2 equals log base 5. And now I have the same bases, so I can drop the base and solve. So x plus 6 times x plus 2 equals 5. This equals x squared plus 8x plus 12 equals 5, which is x squared plus 8x plus 7 equals 0. And then I'm going to factor and solve. So I need 2 numbers that multiply to 7 and add to 8. That's 7 and 1. So x plus 7 times x plus 1 equals 0. So x equals negative 7 and x equals negative 1. Because the domain of x comes from the x plus 6 and the x plus 2, both of those need to be greater than 0. So remember, you set the parentheses greater than 0. So if we did that, if we set x plus 6 greater than 0 and x plus 2 greater than 0, we end up getting x is greater than negative 6 and x is greater than negative 2. So you go with your highest amount. So therefore, your domain of this function is x is greater than negative 2. So we can take out the negative 7 because that is excluded in the domain. Next, we have a natural log function, and we're going to use those properties again. So we have addition, and we have the same base, so we can change that to multiplication. So natural log x times x minus 4 equals natural log of x plus 6. If we distribute that and drop our bases, we get x squared minus 4x equals x plus 6. Put all of your variables and every coefficients on the one side. So x squared minus 5x minus 6 equals 0. We're going to factor and get x plus 1 times x minus 6 equals 0, which means x equals negative 1 and 6. Now let's go check those parentheses. So we have the x minus 4 is greater than 0, and x plus 6 is greater than 0. That means x is greater than 4, x is greater than negative 6. And don't forget the 1x here, where x is greater than 0. And then since our highest, we can exclude the negative 1 in our answer, since our highest was x is greater than 4. Alright, next we have exponents, and we don't really know this one, so we can use log or natural log and kind of use like the change of base formula for these. So I'm going to multiply each side by log and get log 2 to the x equals log 5. And now these have the same base, but I'm trying to solve for x. So I'm going to change this into like the factored form instead of exponential. So that's x log 2 equals log 5. So it's like x times log 2. So now if I want to solve for x, I'm going to divide both sides by log 2. And get x equals log 5 divided by log 2. If I punch that in the calculator, I get that x equals 2322. Alright, for the next one, we're going to do the same thing, but first I have 8 times 3 to the x. I can start by dividing both sides by 8. So now I have 3 to the x equals 5 divided by 8. Now multiply by log on both sides. So I have log 3 to the x equals log 5/8. I'm going to change my left side from exponential to the factored. So x times log 3 equals log 5/8. Solve for x by dividing by log 3. I get x equals log 5/8 divided by log 3. Punch this in your calculator and you should get that x equals about negative 0.428. Okay, for this one, I'm going to use natural log. It doesn't matter if you use natural log or log, you'll get the same answer. I'm just going to use natural log here. So first, I'm going to start by multiplying each side by the natural log. And then I'm going to change from exponential to the factored form. So x minus 2 times natural log 5 equals 3x plus 2 times the natural log of 3. I'm going to add parentheses around the x minus 2 and the 3x plus 2, and then distribute what's inside the parentheses to the outside. So here I would have natural log 5x minus natural log 5, or let's just do 2 times natural log 5. So 2 natural log 5 equals natural log 3 times 3x, and then minus 2 natural log 3. I'm going to get my natural logs with the x on one side and the ones with just numbers on the other side. So I'm going to end up with natural log 5 times x minus natural log 3 times 3x equals 2 natural log 3 plus 2 natural log 5. And now I'm going to factor out an x on the left side, because they both have that in common. And I'm left with natural log 5 minus natural log 3, and then equals 2 natural log 3 plus 2 natural log 5. Now to solve for x, I just need to divide by the natural log 5 minus natural log 3. So let me shrink this. Oops. That's good. So I'm going to divide both sides by natural log 5 minus natural log 3 and get x equals 2 natural log 3 plus 2 natural log 5 over natural log 5 minus natural log 3. Plug this in your calculator and you get about negative 3.212. Alright, next we have this 4x minus, or 4 to the x minus 2 to the x minus 12 equals 0. I'm going to try and get that same base. So I know 4 to the x can be written as 2 squared, and then we have that x, and then minus 2 to the x minus 12 equals 0. This looks like a quadratic function, like an x squared minus x minus 12, a number. So I'm going to replace 2 to the x as x. So I'm going to say 2 to the x equals x. So I have x squared minus x minus 12 equals 0. If I factor this, I get x plus 3 times x minus 4. I'm going to go back and replace my x for the 2 to the x. And then, so I have 2 to the x plus 3 equals 0. And 2 to the x minus 4 equals 0. I'm going to solve for both and get 2 to the x equals negative 3, which that's nothing. And then 2 to the x equals 4, and that's x equals 2. Alright, here is our last example. So we have x plus e to the x equals 2. So we're going to go ahead and use a graphing utility and plug both of these into the calculator. So the first function we're going to put in is y, and this is the first one, so y1 equals x plus e to the x, and then y2 is just y equals 2. And we're going to figure out where these two equations intersect. So if we go to the calculator, and we're going to plug in the two functions, press plot, and then we're going to click near the intersection, press menu, function, intersection, and then the function, and we get that the intersection is at about 0.443. So we can say intersects at 0.443, 2, and we want to know the x value, and the x value was 0.443. If you have any questions, please